All right, in 6.1, we're going to be talking about something called the law of sines. The law of sines. The law of sines is a formula you can use to find angles or sides of any triangle that fits certain parameters. So let's talk about it. So first of all, we can use the law of sines to solve what are called oblique triangles. And sometimes the law of sines leads to what's called the ambiguous case. We'll talk more about that. And find an area and applied problems. Okay, so what is an oblique triangle? It's any triangle that does not contain a right angle, right? So what we've been working on so far is trig with right triangles, right? So here we have right triangle, we've got an angle, and we've got the opposite side, and the adjacent side, and the hypotenuse, right triangles. But with an oblique triangle, we don't have a right angle. There is no opposite, adjacent, hypotenuse. Okay, so how do we use trig to solve oblique triangles? We use either the law of sines or the law of cosines. Here is an example of an oblique triangle has 3 acute angles, or you could have 1 obtuse angle and 2 acute. The relationships among the sides and angles are not valid with oblique triangles. Okay, so we got to do something else. We can't use the sine is equal to opposite over hypotenuse. That doesn't work with oblique triangles. So here's what we use instead. Capital A, capital B, capital C, those are going to always refer to angles. Lowercase a, b, and c are always going to be the lengths of the opposite sides. So if I have a triangle like this, A, B, and C, then the side opposite will be lowercase a, the side opposite will be lowercase b and lowercase c. And what this formula says is the ratio of the opposite side to the sine of the angle is consistent for all of the sides. Okay, this will make more sense with an example. All right. When we solve an oblique triangle, it means find the lengths of any missing sides and the measurements of any missing angles. We can use the law of sines confidently in 2 different cases. And then we can also use it for a third case. Basically, when we know one side and 2 angles, it doesn't matter whether the side is between the angles, like it is here. The side is between the 2 angles or not, right? That doesn't matter. But if you know 2 angles and a side, you can use the law of sines. Okay? 2 angles and a side. 2 angles and a side. And do you remember side angle angle and angle side angle? That's from geometry. Remember back in the day when you were talking about congruent triangles? That's what they're talking about actually, is angle side angle and side angle angle. All right. So we're going to solve the triangle where one of the angles, A, is 64 degrees, and we know another angle, 82 degrees. So because we know 2 angles and a side, we can use the law of sines, and it happens to be that the side that we know is not between the two angles. So here's this angle right here, here's this angle right here, and here's my side over here. It is not between those two angles, but that's okay. This is a side angle situation, perfectly fine, use the law of sines. Okay, so we're going to take the side that we know, which is 14, and divide it by the sine of the corresponding angle, which is going to be 82 degrees. That is in degrees. Make sure your calculator is in degrees. Okay, and that's going to equal either of the other two sides. So let's do B divided by the sine of B, and that will also equal A over the sine of 64 degrees. So I don't know if you notice, and I kind of hesitated, and I hesitated because of this right here. Okay, so when we set up this proportion, this is really just a proportion. When we set up the proportion, we need to know 3 of the numbers, and we need to solve for the 4th. Well, if we used this one, we don't know either the top or the bottom, so we're going to not do that one, and we're going to use this one over here. So 14 over the sine of 82 degrees is equal to A over the sine of 64 degrees. You cross multiply, so A sine 82 is equal to 14 sine 64, and we divide by the sine of 82. And this is where you plug it into the calculator. And A is approximately 8.7 rounded to the nearest tenth, and that would be centimeters, because centimeters. So we have found A. A is approximately 8.7. We also need to find B. We have angle A and we have angle C, so we need to find angle B. That's another thing we need to find. And to find angle B, if we know 2 of the angles, we know that the angles of a triangle add up to 180 degrees. So to get angle B, we would take 180 and subtract off our 64 and our 82. So angle B is going to be 34 degrees. Where is my, okay, 34 degrees. Okay, so the only thing that's left is side B. So 14 over sine 82 degrees is equal to B over the sine. Now that I do know angle B, 34 degrees, I can plug that in and I can cross multiply. So B sine 82 is equal to 14 sine 34, and divide by the sine of 82. I do want to caution you. This right here is a function, right? So a lot of people see that you have a sign on top and a sign on the bottom. We'll just cancel out the SIN, and we should be good. We have 14 times 34 over 82. That's not how it works. Because sine is a function, you can't do that, right? So don't do that. And we end up, after we plug this into our calculator, with approximately 7.9 centimeters. All right, so there we go. We've got our missing angle, and we have our two missing sides, round to the nearest tenth. And this is the same one. Okay. Solve triangle ABC. Angle A is 40 degrees. Angle C is 22.5. And we know side B is 12. So we don't know A, and we don't know C, and we don't know angle B. To prevent what happened on the last slide, let's go ahead and find B first, angle B first. So B is going to be 180 minus the two angles. By the way, we should just double check. We've got the two angles. We've got two angles and a side, and the side happens to be between the two angles. So we have an angle side angle situation. We can use the law of sides perfectly fine. 22.5, and we end up with 117.5 degrees. Okay, so we've got angle B, and we need to find side A and side C. Okay, so we've got all three of our angles right now, and we have one of our sides. So we're going to take the side that we know divided by the sine of that angle, 117.5, and set that equal to, I don't know, let's do side A, over the sine of angle A, which is 40. Cross multiply, you get A sine 117.5 is equal to 12 sine 40. That's degrees. Divide. And plug it into your calculator. Wait to plug it into your calculator until you get A by itself, right? Do not plug that in, get a decimal, and then continue working the problem. Every time you round it, it just introduces a little teeny tiny error, and all those errors add up. So wait until the very end. And we get A is approximately 8.7. We don't have a unit. And then 12 over sine. I could do 8.7 over the sine of 40 to get my C, but I prefer whole numbers, and this has been rounded. Like I said, anytime something is rounded, it just introduces errors which get compounded. So we're trying to find C, sine of C, and cross multiply. That should be degrees equals 12 sine. Reminder, your calculator has to be in degrees. Why do I keep reminding you? Because it's really hard to remember to do it. And how do I know that it's really hard to remember to do it? Well, I was a student once as well, and guess what I always forgot to do? Change it from radians to degrees or degrees to radians. So it's super easy to forget 5.2. So I've got side A, B, and C, and I have angles A, B, and C. And this was an angle side angle. So remember, two angles and a side. Doesn't matter where the side is, two angles and a side. And this is the same one. Okay. Now we get to what's called the ambiguous case. Again, let's go back to geometry. When we were doing geometry, I don't know if you remember, this a while ago. When you have an angle, side angle, that's going to be congruent to a triangle. Those triangles are congruent, and side angle, angle, those are going to be congruent. But if you do side, side angle, those triangles are not congruent. There's issues with side, side angle. And how do I remember that side, side angle is a problem? Well, because I usually remember it like that. And I'm going to erase that. There we go. A side-side angle it can cause problems, especially when we're doing the law signs. You get what's called the ambiguous case. So here's the problem. When you have side-side angle, let me see if the next slide has a picture. I hope it does. Aha! There are possibilities that could happen. You could have one single triangle, right? You could have a right triangle, one single right triangle. You could actually have no triangle at all, right? So if my side A is too short, you don't end up with a triangle. It's also possible that you could end up with two triangles. Depending on the angles, it really depends on the length of side A. Okay, assuming this is the angle that you know. So for convenience sake, the side that we know, or the angle that we know, we're always going to call that A. It really doesn't matter what letter we call it, but for clarity's sake, we're just going to, the angle that we know, we're always going to call that A. Okay, so side A, it could be too short, it could be, just too many situations to, yeah, ambiguous case. All right, now, there are ways to determine which case you have, and kind of if you figure out what the height of the triangle is and then compare it to your side A, that will help determine whether you have one triangle, a right triangle, no triangle, or two triangles. There is actually an easier way, and I'll kind of show you the easier way. Okay. Anyway, let's move on. So let's suppose we have a triangle ABC, and we know angle A, and we know side A and side B. So we have, okay, we don't know how long this side is. We're going to label this A, and we are going to label this C. And I'm just going to put side A, and I'm just going to put it as 10. It could be longer than what I drew it. It could be shorter than I drew it. But for now, I'm just going to draw it like this, okay? So I'm going to use, oh, and so we have side B is going to be 20. So here is my point B. Okay. So we know side B, we know side A, and we know angle A. So we have an angle side, side, or if you want to say it properly, we have side, side, and then the angle that's not between them. Okay. So we're going to use the law signs. We know that side A is 10, and the sine of this angle. And what we're going to do is set that equal to 20 over the sine of B. All right. So we're going to cross multiply, and we have 10 sine B is equal to 20 sine 50. Divide both sides by 10, and we have the sine of B is equal to 2 sine 50. So there's a couple different ways you can do this. You can find 2 times the sine of 50 degrees. If you do 2 times the sine of 50 degrees, you end up with, I don't remember, and I didn't write it down. This is going to be a number bigger than 1. Bigger than 1. And that's impossible. When you take the sine of something, you cannot be bigger than 1. Remember our sine graph? Biggest is 1. So you can't go up and be bigger than 1. Okay. All right. So the other way, and probably the easiest way, is to do the sine inverse of this on your calculator. When you do that, when you plug it in, your calculator is going to say undefined. That doesn't mean your answer is undefined. It means that your angle B is undefined. Well, if you don't have a defined angle, then you don't have a triangle. So no triangle. If you want to triple check, I'm going to call this H, you can find the height of the triangle, and the height is actually going to be taller than, this says, it's hard to read, A equals 10. It's going to be bigger than 10. And so you have this side that's just kind of swinging back and forth, never actually hits this side right here. So triple check, the sine of 50 degrees is equal to the opposite side over the hypotenuse of this little right triangle in here. And H is equal to 20 times the sine, 20 sine of 50. And if you do that, you get approximately 15.3, which is bigger than 10, right? So this is 15.3, and this is only 10, so it never actually can touch this side right here. So 3 different ways you can check. Long story short, no triangle. All right, now we have an angle A. For convenience sake, we're going to make that 35 degrees. And here's my B, and here's my C. And now we've got a side, and I'm just going to draw it like this. And B is 16. Okay. So we are going to do 12 over the sine of the angle that we have. And we're going to do b. We're going to do sine of b. So 16 over the sine of b. And we cross multiply. So 12 sine b is equal to 16 sine 35 divided by 12. And we get sine of b is equal to 16 sine. We can simplify this. 4 goes in there 4 times, 3 times. It's actually a 4 sine 35 degrees over 3. And to find b, we could do the sine inverse. 4 sine 35 over 3. And we rounded the angle rounded to the nearest degree gives us 50 degrees. Okay. So let's call this 50 degrees. Okay. But if we add there are 2 different angles that will give us this, right? There's 50 degrees, but there's also an angle over here in quadrant 2 that is a positive. And so to find that, we would take 180 and subtract 50. So B could also be 180 minus 50 degrees, or 130 degrees. Okay. Now, when we find this one, the bigger one, you have to double check and make sure that it actually makes a triangle. What do I mean by that? Hold on. If this is 130 and this is 35, you have to check and make sure that you can actually fit an angle right there. So if you take 35 plus 130, that has to be smaller than 180 degrees, which it is. It's 165. So this angle right here would be 15 degrees. Okay, and that works. Certainly 50 plus 35 would be smaller than 180, right? So to get this angle right here, you would take 180 minus the 35 and the 50, and that gives me 95 degrees. Okay, so what do I mean by this one over here? You have to check and make sure. So what if my angle here, what if this had been 150 degrees, right? And this is 35. Well, 35 plus 150 gives you 185. That's too big. That's too big, and that wouldn't work. So we would not have this triangle here. We would just have this smaller angle over here. Okay, so but that's not what we have. We got 165, so we have an angle 15 or an angle 95. Okay, so B could be 50 degrees, which would make C 95 degrees. Or B could be 130 degrees, which would make C 15 degrees. Okay, so basically we have two different triangles, and we have to find side C for both of them. Let me erase this down here so I have some room. Eraser. I'm going to erase this down here. Okay. Erase that. Give myself some room here. Okay, so I found all three angles for both triangles. I just need to find C's for both triangles. So B is 16, A is 12, and I'm trying to find side C. So over here, I would do, what am I trying to find? Side C over the sine of 15 equals, yeah, let's do side A over the sine of 35 degrees. Cross multiply. Sine 15, divide, plug it into your calculator, and you would end up with C is equal to 5.4 approximately. And do the same thing over here. C over the sine of 95 is equal to 12 over the sine of 35. Cross multiply. C is going to be 12 sine 95 divided by the sine of 35. Plug that into your calculator, and you get C is approximately 20.8. Whew. Yeah, we don't like this side-side angle thing. Oh, those are the two different cases. It could be either 50 or 130, which would make angle C 95 or 15. Okay, you guys know that area is equal to 1/2 base times height. Well, sometimes we don't know the height. Okay, so how do we find the area if we don't know the height? Well, we basically have to find the height. So if we use this angle right here, we have this imaginary right triangle, then the sine of that angle is equal to the opposite over the hypotenuse. So the sine of A is equal to the H over B. And if you multiply both sides by B, then one way to write the height is B sine A. So this right here is one way to write the height. Well, there's my B sine A. C would be my base of my triangle, and this would be B sine A. So 1/2 B sine A times the base. Okay, that's one way to write the height. But there's other ways. We could look at the sine of B. Sine of B would be H over A, multiply both sides by A. So this time the height is A sine B. Here's my A sine B. My base is still C. And I don't want to redraw the triangle, but that's basically the same. Okay. All right, so essentially what you're doing is you're finding the height of the triangle by using the sine. All right, here we have we know this angle right here. So we're going to end up taking the sine of C. So the one where you did the sine of C, it was 1/2 A times B. 1/2 A times B sine of C. So area would be 1/2. My A is 12. And my B is 8. So 1/2 times 12 times 8 times the sine of 135 gives me approximately 34. That was in meters. An application. 2 fire lookout stations are 13 miles apart, with Station B directly east of Station A. Okay, so we have north, south, east, west. Both stations spot a fire. The bearing, remember the bearing? It's the number of degrees to the north-south line. The bearing for A is north 35 degrees east. So this is 35 degrees. This is going to be a right angle. So this would be, what's 90 minus 35? That is 55 degrees. Okay, so angle A is going to be 55 degrees. And then the bearing of the fire from Station B is north 49 degrees west. Okay, so you would take 90 and subtract, right? This, again, is going to be a right angle here. Subtract your 49, and you end up with 41 degrees. So we know 2 angles and a side. When you know 2 angles and a side, you can use the law of sines. 2 angles and a side. We need to know how far is the fire from Station B. So we're trying to find this side right here, which is side A. Side A. So we're trying to find side A. So A over the sine of 55 degrees will be, we're gonna need this angle right here. So 180 minus my 55 minus my 41, C is going to be 84 degrees. So 13 over sine of 84 degrees. Cross multiply, a sine 84, 13 sine 55, divide, and we get A is approximately 11 miles. It said to the nearest tenth, but I didn't write down to the nearest tenth. So we're just going to have to go with 11 miles. Okay. Same problem. And the lesson reflection.